And few other plots are also obtained from these explore command. So I'm going back to the explore command you see here. So analyze, descriptive, explore. We see the variables, those were selected earlier are lying in the columns. And now I am clicking the button plots. So here few of the plots can be obtained. I'm unchecking this stem and leaf because we don't need stem and leaf here. You click this histogram, and then we have normality plots with tests. And by checking these two options, just pressing the continue button and then pressing again the OK button. So these are the output of the description. Those were obtained earlier. And now we have few more graphs available on the output. See here, this is the histogram of the yield number 4. And you see here, we cannot say that this is symmetrical. As you see here, it looks as if it is slightly positive skew. And now if you look at yield number 4, so it has a histogram where there is a gap in between. So it's very confusing and we cannot have an idea whether your data has a symmetrical pattern or a skewed pattern. So why it is so? Because the histogram is a subjective approach to judge the skewness in the data, and in many situations it is misleading and we cannot exactly have an idea whether what sort of a shape of the data can be on the basis of histogram. Since we have only 16 observations, that is one of the reason that your histogram is not clearly indicating the shape of the distribution. In case we have more values, at least 30-40 values, then might possible we have a better output and the shape on the histogram of the data. And again, I would say this is a subjective approach to judge the symmetry and the skewness from the histogram. And now we have a normal probability plot. So these are some of the plots through which we judge whether our data follow normal distribution or not. So these are called normal probability plot, normal QQ plot of the yield number 4, and then we have normal probability plot for the yield number 8. For a data that is following normal distributions, these points are very much close to the line, this diagonal line, upward sloping line. If these points are very close to this line, that is an indication that your data follow normal distributions. So here we can see that all these points are quite close to the line and there is no point which is getting away from this line. So similarly in the yield number 8, you can see the same pattern. We can see here that all these points are relatively very close to the point, and that is an indication that your data for the yield number 8 also follow normal distribution. But again, I would say this is subjective approach to determine the normality of the data. So we have so far discussed few approaches to judge the normality. This is the second one. The first one was comparison of the skewness and the kurtosis. That in case the skewness or the kurtosis or both are significant, your data cannot be normally distributed. And in case both of these descriptives are non-significant, then we can say that data are following normal distributions. And then the second approach I have explained to judge the normality of the data is to see this normal probability plot, that if all these points are close to the line, this diagonal line, It indicates that your data follow normal distribution. So you see here in the yield number 8 and yield number 4, the pattern are almost same. But the two approaches I have discussed here to judge the normality, both of these approaches can be considered as subjective approaches to judge the normality. And now in the last, we have an objective approach through which we can determine whether your data follow normal distribution or not. And that is the normality test. Here we have an output that is indicating the normality test. And usually uh, the most preferred test is Kolmogorov-Smirnov test, and the second is the Shapovalov test. The Shapovalov test, sometimes your Kolmogorov test is not giving us any measure because of the small number of values in the sample. So you can say in case we have a 5 observation in the sample, then Kolmogorov-Smirnov test cannot give us any information related to the normality, but the Shapovalov can give us. So here in this output, we have both these tests, which is Kolmogorov and Shapovalov, but I would prefer the Kolmogorov-Smirnov result. And now the question is how to determine whether your data follow the normal distribution or not. So to determine this, we have a column here, the significance here. This is the column where from we are going to decide whether your data follow normal distribution or not. So in this Kolmogorov result, the p-value, this significance value is known as p-value. If this p-value is greater than 0.05, your data follow normal distributions. So as you see here in the yield number 4, the p-value is 0.20, which is greater than 0.05, so it follows normal distribution. And similarly in the yield number 8, your p-value is 0.165, which is also greater than 0.05. So we can say that your both yield types, yield number 4 and yield number 8, both follow normal distributions. So this approach is objective approach to judge the normality. So that's how we determine the normality of the data, for which we have three approaches. One was comparison of skewness and kurtosis statistics. The second I explained is the normal probability plot, and the third one is the normality test, which is called Kolmogorov-Smirnov test or Shapovalov test. So here you see both of these tests are insignificance. This value is greater than 0.05. This value is also greater than 0.05. And the p-value is pertaining to the yield number 8. The Kolmogorov's p-value is greater than 0.05, and the Shapovalov's p-value is also greater than 0.05. So both of these values are indicating that your yield number 4 and yield number 8 are following normal distributions.